think everybody's admitted now. Okay, so let's get rolling here. I'm gonna pop this open. Well, actually, let's show Blackboard first. Okay, so I'll share that screen. I do have multiple monitors here, so if you see me looking up when I'm talking to somebody, that's what's going on. Okay, you can see my shared screen here. All right, so just as a starting point, most of you should have already seen this. Class is open. Over here on the left, you have this thing called a self-assessment template, which I'll talk about here in a few minutes. There'll be a link to the course slides, which I actually can update right now so I don't forget. So these course slides will always be up to date. So actually you'll have a pre-populated set right off the bat, but you can, as we add stuff to it, so I kind of have a template, but then I'll go off course pretty often and we'll add stuff. So you'll always have the most up-to-date version of the course slides. So that should be updated now. If you happen to click the link, you'll be looking at the same thing that I'll be looking at and sharing here in a few minutes. Also, I record every one of my classes, so I use Zoom recording for this semester. I actually used it last semester too. So after each class, I'll upload the video to YouTube. I'll put a link to the playlist for this class up there. I record all of my classes for the last, I don't know, decade or something like that on YouTube. So you can go back and look at previous versions of this class if you want to see things. Somebody's saying they're lagging out. So is it stable enough? Is this just a them thing or is this an everybody thing? All right, whatever.
I'm good.
Okay. But yeah, like I said, you know, if you do have some connectivity problems when you are doing the Zoom version of the class, I always record every class. So, you know, if you want to have something to help put you to sleep at night, you can always go back and rewatch the lectures, or a lot of times before homework assignments, I'll kind of give you kind of a starting point or give you a hint or something like that. So, and I do a lot of live programming, especially after we get past maybe the first couple weeks of class. Up front, we're doing kind of a foundational thing, so you won't really see too much code yet, but I promise you'll see plenty of programming this semester. But with that said, you'll always have access to class materials, whether it's rewatching the video, being on Zoom, seeing it live, or being in person, and we'll talk about that here in a few minutes. Also, we have a Slack channel for class. So if you go to cuwcs.slack.com, if you haven't used Slack before, it is a kind of a multi-user chat program. They use it for a lot of businesses and things like that. If you don't already have an account on there, some of you have had previous classes, maybe you have an account. Otherwise, you can create an account, and when you log, you just use your cuw.edu email, and it'll just let you in. and there's apps for iPhone, for Android, for Mac, for PC. You can also do it on the web, and it'll bring up something that looks like this. There's a class called CSC200 over here on the left. Just click on that and you'll join that class. So I very, very, very commonly will post things on here. Also, it's a good place students can set up private channels if you want to do homework study groups, things like that. Also, if you're working on homework and you have a question, post it in here on the 200 link. I usually answer things pretty quickly, but if one of your classmates has already solved that problem, they're happy to respond into, so you can get pretty close to real-time responses to stuff. So you should be checking Slack at least once a day. And you can set up notifications just like text messages, so you'll know it'll pop up on your phone like you actually got something. So just set up notifications for maybe the 200 channel and any other classes you're in. You can mute general if you want, because I also have stuff on here. We post different things in general. We also post internship opportunities in I have a lot more channels than you'll probably see on yours, but in a student opportunities channel, we post internships. So, go through, look at the channels. If things seem like they might be interesting to you, set up notifications for those, because it'll be very common for us to post stuff on Slack, and your other teachers will likely use it as well. And you don't want to be the one who misses something on Slack. I might update a homework assignment and say, oh, well, some people are running into problems with X, Y, and Z, so you can just forget about Z. Well, I might not send an email about that because Blackboard doesn't work well on the phones, and I have to wait till I get back to my computer, but I can do it with Slack, from my phone wherever I am. So check Slack. Everybody cool with that? All right, so again, it's cuwcs.slack.com, and I'm pretty sure that's what this Slack channel link will take you to. Yeah, I think it did. Zoom Classroom, you all made it here today, so that's where it's at. Like I said, you'll have class recordings here as soon as we're done, and I upload the first video onto YouTube. I'll put the playlist link here, so you can just click it and get to all the class recordings. I won't commonly use this class announcements thing. I just happened to do it this first week when I was sending out some emails, and people were still adding and dropping classes, so I just kind of put it on here. So if you didn't get all the emails from class, you can click on this class announcements thing, and you can kind of read the couple of things I've sent out up to this point, but most of you are here today, so you kind of know what's going on. But I'll recap this a little bit. So I'm sure you've heard this spiel from some of your other classes, but obviously this is somewhat of a unique semester, right? So we're attempting to do face-to-face classes, which is great. Some of you might like that, some of you might not like that, and I respect both sides of it. So in all of my classes, and your professors are going to have different feelings on this or different policies, but in all my classes, you can do either online or face-to-face. I don't care what you do. I'm going to teach the class the same way. I'm running class today the same way I'm going to run it when we're face-to-face. I'll just have, instead of this computer screen in front of me, I'll have people. I'm going to still open up a Zoom session. I'll still have some online audience, some face-to-face audience. I'll still record it. All the stuff will be the same. So it doesn't matter to me whether you're online or whether you're face-to-face. But this class does have something like, I don't know, 38 people in it or something like that. And the classroom that we're in has, I think, a COVID capacity of 22 or 21, something like that. So what some teachers will do is they'll say, okay, well, half the class is class A, half the class is class B, and you guys just switch, flip-flop who shows up in person and who doesn't. Well, some of you might hate online. So now half the time you're being forced to do something you hate. Some other of you hate in person because you put pants on. So you might be feeling, that, okay, I have to dress myself those days. So what I've invited everybody to do, and several of you have already done it, but just in case you missed it, if you have a strong preference for being face-to-face, if you've already emailed me, you don't have to do it again. But if you have a strong preference for being face-to-face, send me an email. It's michael.littman@cuw.edu. You can also message me on Slack if you want. In any ways, let me know that you have a strong preference for face-to-face, and I'll add you to that list. The hope is, when all is said and done, we won't have more than 21 people who have a strong preference for face-to-face. If we do, we'll burn that bridge when we get to it. But if we don't, then I'll invite those people who say, I really, really want to be face-to-face to come to every class face-to-face, and the people that are fine with online can then attend online. And I'll mention that, hey, we have an extra 8 slots open if you want to be face-to-face and you just didn't want to say you had a strong preference, and that'll work out. So we'll see how that goes. That way we can accommodate everybody in the way that best fits their needs, and we'll just adapt as we go. But like I said, you're going to be getting the same experience either way. I'll run the class identically to this. And you'll still have to unmute yourself and scream, especially if I'm in the normal classroom and I have students, out in front raising their hand or whatever. So you're not going to offend me, so don't worry about that. Okay, so any questions about how class is going to work, and if you have a preference for face-to-face, that you should email me like by the end of the day today type thing? And by end of the day, let's just say call that noon, something along those lines, so I can get those in my spreadsheet as quickly as possible and reach back out to the class so people know who is safe to come to class on Thursday and who probably should stay home, that kind of stuff. Let's see, what are the classroom policies? I think I linked it in the email, the whole uncommon return policy flippy dealy thing. I didn't write it, so that's what the university's policies are. I think when you're in the classroom, you have to have a mask on. I think there's no eating and drinking, at least no eating, I think, in the classroom. Follow the rules. I'm not going to be the police officer for this stuff. If another student throws a punch at you, I'll probably just laugh. So, yeah, I don't know. Follow the rules, do the thing, and we'll all get through this together is going to be the dealio. Yeah, I think that's basically the thing. If you're in school and in the classroom or in the halls, you have to have a mask on. I think that's the rules. That's the shorthand version of it. All right. So any questions about any of that stuff? Okie dokie. Now let me go to. I'll switch over to. Well, here, let me just talk about it here in case I don't have an example of it in the slides. So I have this thing, and you'll have this in all my classes, so you'll be pretty used to this as you get to your 4th year of school here with all your, let's call it all your programming assignments. If you have a paper or we have Bible homework every week, I'll talk about that in a minute, you don't have to turn in the self-assessment for that. But really what it comes down to is computer programming is hard. And we're going to talk about this here in more detail as I kind of get into the course material. But it's not uncommon for you to sit there and spend 3 or 4 hours on your homework and have nothing to submit. You just, everything you did, you sucked at, and it kept getting errors and errors and errors, and nothing worked, and all this stuff. You have nothing to submit. Well, my preference would be if you put a lot of effort in, I don't want to give you a 0. I kind of will talk about, and I'll say it again here in a few minutes, but computer programming is kind of like a sport. You got to put in your reps to get better at it, and pick, any of you can pick your favorite sport, soccer, baseball, whatever. And when you first started playing that, you probably weren't very good. And over time, through practice and making a lot of mistakes, you started getting better and better and better. And your coaches rewarded you for showing up to practice and working hard, even if you didn't perform as well as they hoped you would perform 3 years from then, right? Okay. Well, computer programming is kind of the same thing. So when you turn in an assignment and it's complete garbage, but you put a lot of effort into it, you learned a bunch of stuff from it, you just don't have a great result to show me, this little document is your ability to kind of tell me what went down during your experience during your assignment. I want to know how long you spend on it, based on how hard you worked, what do you think you deserve? Based on what you actually gave me, what do you think you deserve? And then the last one's probably the most important. Tell me kind of where you struggled, things like that, so I can kind of zero in on the area of your program that, needed some extra love, something like that. All right. I want to grade homework. Homework is practice. I want to grade homework as you're preparing for the big game. All right. So if you work hard on your homework and you get it submitted on time and you've put in the effort, even if it's not perfect, you're going to get a good grade on it. Okay? I'm going to find out on the exams whether you're learning anything. At the same time, again, programming is hard. I encourage you to form study groups. Maybe get into a group of 2 or 3 people who get together and work on their homework together. I don't care. I'm not going to be sitting here policing when your code looks identical to somebody else's code. I'll find out on the exams whether you're learning as much as you need to learn off the assignments. All right, you're only hurting yourself if you're gonna just get somebody else's answers on the homework assignments because you'll come and bomb the exams and whatever. All right, so self-assessment should be turned in with every single computer programming assignment so that I can marry up what you actually submitted with what your experience in doing it was and give you a grade that's indicative of, did you show up to practice and work hard that day, as opposed to what did you actually hand me at the end of the semester? Everybody cool with that? All right. And every homework assignment has a Dropbox. So what you can do is you'll submit your homework to the Dropbox, and then you can actually just copy and paste the self-assessment into the little text box for the assignment. And I mean, you could always attach it as another document too if you want, but it's easier for me to read if you just put it into the little notes box when you submit. Okay, so we did that, covered that. Okay, so let me stop share, screen share. All right, you can see the slides now, right? All right, so assessments in here, and this is mimicked on the syllabus that's on it's on Blackboard. You can go read it's a bunch of blurbs and stuff about policies and that kind of stuff, but it's up there. But effectively, for how your grade will be calculated, we have 2 different kinds of assignments in class. We have Bible homework each week. So hopefully most of you are aware this is a Lutheran university. And computer science is a little bit weird in how we can incorporate a Christian worldview into the classroom. We do it through some of our assignments and things like that. I also recognize that all of you are Lutheran, not all of you are Christian, and that's fine. I respect that, but you're still going to do the Bible homework. So Bible homework, the way it works effectively is every single week you read 2 chapters out of the Bible. Shouldn't take you very long. And then you write a small little paragraph kind of responding to it and how it relates to your degree in computer science, which could be sometimes a little bit made up, let's say. But you'll get 100% on the assignment, right? So what is this forcing you to do? It's forcing you to read the Bible once a week, at least. And then write a little paragraph and submit it and get 100% for 10% of your grade. Good deal? All right, so that's due by midnight every Sunday. Some students who've had me for a long time, they knock them all out. They're already all up there. They do them all at the front of the semester, which is fine if you want to do that. That's kind of defeating the purpose. The purpose is getting you into a habit of reading the Bible every week. But, for your own time management, or you don't trust yourself to remember to do it every Sunday, whatever it is, or do it by every Sunday, you're all adults. So figure out what's works best for you. I would just pick a night during the week that you think are usually free, set an alarm for that, and spend your 10 minutes reading, writing a couple of sentences, and move on with life. All right, questions about Bible homework? There should be a free 10% of your grade. Turn it in. Don't forget to turn it in on time. It's so common for students to do well in a class and then just not even do the Bible homework. Just it is what it is. Homework assignments, most of which will be programming assignments, are worth half your grade. Okay, and those are the things that I'm encouraging you to, work in groups. You can work individually, that's fine. But like I said, programming is hard, and there's going to be some students in class that pick up on it quicker than some others. And, other students are going to need some extra help. And sometimes the way I'm explaining something in class, or when I demo something, it might make sense once you see it, but maybe it's easier to hear it from one of your classmates or something like that, or the way they're approaching the problem makes more sense, whatever that is. So Again, I'm not going to be looking for plagiarism or anything like that on your assignments. You're only hurting yourself and your adults. So strongly encourage you to form some study groups. If you're interested in study groups, maybe just put a post into the 200 channel on Slack, and hopefully through that, some people will coalesce into maybe a group, and you can kind of look at each other's schedules and decide what makes the most sense. And like I said, you can create private channels on Slack and just invite people into it, so you can have your own little study group Slack channel where you can ask questions and say, hey, who's getting together tonight on Wednesday to work on assignments, whatever it is. Okay, so there'll be 2 exams in the class, a midterm and a final, each worth 20%. My policy is that if you do better on the final exam than you did on the midterm, I'll replace whatever you got on the midterm with whatever you got in the final. My job at the end of the semester is to give you a grade that indicates how well you've mastered the material. Some of you are going to show up to the midterm and either things haven't clicked yet, or you're going to recognize that you've been getting too much help on your homework assignments, things like that, and you're going to bomb the midterm, and that should be a wake-up call, but it's fixable. Come in, do better on the final, and you can wipe out a 0 on the midterm with, a 90 on the final. Now you have 2 90s. So hopefully you see I give you every opportunity to succeed. I guess take advantage of that, and don't come whining at the end that oh, can I turn in all these assignments late and stuff like that, when the answer will just be no. If you have extenuating circumstances, I get it, sicknesses in the family, things like that, I'm not a jerk. So if you do need an extension on something, or sometimes I'll just say skip that assignment and we'll just count the next one twice, that kind of stuff, because I go through every assignment in class after it's due. So true extenuating circumstances, do talk to me. We'll work it out. But hey, I forgot to do it isn't going to cut it. Okay. Questions about any of the grading, assessment, stuff, thingy-majiggies?
I got a question.
Sure, go ahead.
So when are we going to have Bible homework due? Is that every Sunday, you said?
It's due at midnight every Sunday. And all of them are already up there. So every week you read 2 chapters. So all the assignments are already on Blackboard. Every week you read 2 chapters. It's from the book of Acts this semester. And then you write a couple of sentences response to it. It's 3 points, just you have to do it. And it's getting you into the habit of reading the Bible.
So we have that assignment starting today?
Well, it's due this coming Sunday. So yeah.
All right.
And like I said, every one of the Bible homework assignments are already up on Blackboard. So you could sit down and just knock out the book of Acts tonight if you want, and write all your responses and be done with it for the semester. I'm not encouraging that, but because that kind of defeats the purpose. But if that's your style and that's what you want to do, and you don't have too much homework right now and just want to knock it out, it's your rodeo. So you can certainly do that, and all the assignments are already up there. All right, other questions? Okay, so we have 7 books for the class. Each one costs $100. So I do have a couple of, an interesting book. First of all, there's no required book for the class. So everything will be either online resources or things I cover in class. If you, there's this interesting book that I just put up as supplemental. I will not refer to it at all in class. This is more of a framework for computer programming. It's called the Pragmatic Programmer. Actually, that probably didn't open up for you guys. Let's see, for Kindle, it's $27. But it really has nothing to do with programming, learning to program. It has more to do with the mindset of a programmer. It's an interesting book. You can find if you can find a used copy or something like that, and you like reading and you want to give yourself some kind of non-academic context for programming, it would be worth looking at. But I'm not going to reference it in class. It's not going to be part of any assignments or anything like that. This is more of a, hey, here's a cool book related to programming that's just kind of more for humans to read about computer programming than it being a teach computer programming book. Okay, that makes sense? So you don't have to spend money on that if you don't want to. I'm not going to reference it. It's a suggestion. All right. We will be doing quite a bit with Python. So I've linked you to the official Python documentation here. That'll be your, let's call it online textbook, but most of what you'll need, I'm going to give you. All right. So you won't need an extra book or something like that. If you do happen to want a programming book that has some extra examples in it. I mean, there's so many resources online. And like I said, I already mentioned several times, we use Python in here, which is an industry standard language. You'll find 4 zillion examples of Python stuff online. In the next class, you'll be using Java, another industry standard language, blah, blah, blah. So, the punchline is that there's plenty of examples of coding stuff online that you can look at and kind of reverse engineer. And I'll be giving you examples in class. And after every homework assignment, I solve the assignment in class at the beginning of the next class. So you see the process of going through there and doing it. So we will spend part of our class time, each class, solving the assignment that was due that day. So you'll kind of see like, oh, that's where I went wrong, whatever, that kind of stuff. Okay, so you don't have to spend any extra money on anything. We're good with that? All right. I already talked about the self-assessment thing. I just wasn't sure if I had included it in the slides or not. So again, that's in there. Okay. So I throw this thing, so that covers the bookkeeping for the class. Everybody kind of knows what to expect. Pretty much I'll have a homework assignment every single class, unless I just don't get to something that you really need to be successful with the assignment. Again, the assignments are more of like practice. So think about, if you are on a basketball team or a baseball team, I want you to have lots and lots and lots of practice opportunities so that when you get to the big games, you have the practice under your belt. That translates into, you might spend more time in this class and you might spend on some of your other classes because of the nature of programming. Programming is complicated. And it's kind of like a sport. You can't just academically study for the exam the night before and expect to do very well. My exams are programming exams. They're not like fill in the blank, multiple choice, true, false. So you'll have to write code. And I promise you, I've been doing this for a few minutes. This is my 21st year teaching. And it's very obvious when somebody pretty much knows what they're doing and pretty much doesn't know what they're doing. I'm not looking for perfection, but there's a huge chasm between somebody who's competent in it, has put in the reps on the homework assignment, and the person who just tried to cram the night before for the exam and wants extra points for using a colon in the right place or something like that. So in any case, this is a kind of a Python programming template that we'll come back to when we actually start getting into the programming stuff, but it's already in the slides, so you have access to it. So don't worry about this for right now. In terms of the units for the class, things that we will cover, I mentioned before, we're going to be having kind of the first couple of weeks, we'll be having a programming intro, and we'll also get our environment set up for the class. One thing I like to do, so let me kind of tell you about the environment thing a little bit. It'll come up in another slide, but I'll just go ahead and babble about it right now. How many of you have ever heard of an operating system called Linux? At least heard of it, right? How many of you have ever run Linux? Okay, just a couple of you. All right, so one thing that I like to do in all of my classes is keep you out of your comfort zone. And I do the same with the programming languages. You're going to see here in a couple of slides that one of my beliefs is that computer programming is the skill set. The language doesn't matter. So once you learn how to program in Python, you can go pick up Java very easily. You can pick up C# very easily, C++, C, whatever. Programming is the skill set. So what I like to do is you go through the various classes in the program that are going to be involving computer programming. Each time I switch languages on you, which forces you into the belief that, oh, after you get through the initial, the syntax is a little bit different, like, oh, so this is how you do it in Java. This is the same thing as it was in Python with just you flip these two words, something like that. You see how similar they are to each other. Well, kind of the same thing goes with operating systems. Most of you have been using Windows or Mac for years and years and years, and there's nothing wrong with that. But very few of you have done anything with Linux, which is going to put you out of your comfort zone. Now, Linux is also a pretty popular operating system for, I would call it, low-level computer programmers. I mean, if you're a iOS, iPhone, Mac developer, you're probably going to be running a Mac. If you're a .NET, C# type Windows developer, you'll be running Windows. But if you're just kind of that generalistic developer, Linux is a pretty good choice, and it's free and all this stuff. But even if you never run it again, you're going to be running it for this class, is the the punchline. So we're going to be using Linux in here. The one I recommend for the class is the version of Linux that comes on the Raspberry Pi called Raspbian, and we'll actually be running it inside of a virtual machine. The reason I choose Raspbian is not that Raspbian's overly good, and it's not that actually has most to do with it. It doesn't take up a lot of system resources, and since we're going to be running it through a virtual machine, which we'll talk about either later today or next class, it's sharing some of your system resources on your computer. So it's a fairly lightweight install and won't slow your computer way down, that type of thing. But everything you're going to be using, again, is free. It'll go take you through some technical things of setting up Linux on your computer and running as a virtual machine and things like that. It'll also, I'll be doing all of our example assignments in here using Raspbian. So you can kind of see, there's a bunch of tools for Python already pre-installed, so everybody will be using the same stuff. So if you feel adventurous and you kind of know what you're doing with technology and you want to do a different version of Linux like Ubuntu or something like that, that's fine. Bottom line is I want you using Linux to do all your homework assignments in here. Here, I can give you a quick. Just be able to share this desktop. Oh, don't I have a Raspbian on here? Where's the rest of my desktops? So this is a virtual machine running Raspbian. So it's so this is what it'll look like. You can see the screen on my computer, right? It's like a sunset looking thing. Okay, so this is a whole nother operating system, the Linux operating system running on my, I'm on a Mac right now. So when I go to do programming stuff, you'll click the little Raspberry, go to programming, and inside here we usually use the Thonny Python IDE thingy. So, you know, we can write some of our code in here for so there's Hello World running in there. So, you know, the punchline is, you know, we'll be doing our programming in something like this, but this just forces you into using a, you know, an operating system you're not necessarily familiar with. But you see here that it's pretty run-of-the-mill. You got your start menu, you got a terminal here, which a lot of you probably are not necessarily used to using. So we'll do some command line stuff in here. But that'll be the punchline. So part of what we'll be doing the first couple of weeks here is you'll be going through the process of getting that environment set up. I'll give you a video for installing, for most of you, you'll be doing following a video that says installing Raspbian on VirtualBox. Okay, VirtualBox is a free virtual machine software for Windows and Mac. It's made by Oracle. You download it for free. It gives you a computer made in software that you can then download the Raspbian ISO for and install it on your computer without messing up the rest of your computer and all that stuff. And then you launch Raspbian as if it's an application. Okay. So let's see. So the first couple of weeks, we'll be talking about kind of the background in programming, setting up our environment, virtual machine stuff. Then we get into the actual programming stuff. So variables, dealing with numeric stuff, strings, lists, tuples, dictionaries. These are all Python data types. I don't expect you to know any of these things. This class assumed you've never had programming before. If you've had programming before, that's fine. I encourage you to try to challenge yourself on assignments and throw some extra stuff in there if you're finding them too easy, because the rest of the class, I promise, will eventually catch up to you. And if you don't put in the reps now, they'll surpass you. All right, so everybody's going to be in the same boat here, but I assume you've never seen programming before. We'll then get into logic stuff, conditionals, loops, functions, and that'll make some sense here in a few minutes. We get into object-oriented programming through classes, and then we'll work with some database stuff to give you a context for what's the purpose of a database, how does it fit in the world of programming, yada, yada, yada. Okay. So we're good with that? All right, you can go through and read this, well, heck, I'll just read it. All right, so elevator pitch for Unit 1. So we're going to get our Python development environment set up and ready to start programming. This will involve setting up a virtual machine running Linux. We'll also gain a strong understanding of what computer programming means. At the end of Unit 1, we should have an appreciation that computer programming is a skill set and the language we choose to use isn't important. While we are using Python programming in this course, it is accurate to state that the course is an introductory course to computer programming and not a course in Python. All right, so this next statement here is something you're going to hear me say over and over and over again through probably your entire 4 years. How do human beings solve problems? Well, we remember things, we ask a lot of questions, and we have repetition. 100% of programming languages have facilities for these three things. That's the job of a programming language, is to allow us to tell a computer what to do. And rather than us have to meet the computer halfway, speaking zeros and ones, we get to talk mostly like humans, and the computer is going to somehow, using some various tools, translate that into the equivalent zeros and ones. Okay, so this is that video I referenced before, so it's already in the slides. So you watch this video, you'll install Raspbian and VirtualBox on your computer. Again, this doesn't cost a dime. I also will emphasize this is not something that's required to write Python. In fact, how many of you are Mac users? All right, 4.5 people. All right, so we have 4.5 Mac users. You already have Python installed in your computer. Windows, you'll have to install Python if you want to do Python stuff on the Windows thing, and that's from a website called python.org. But I will throw you might want to make a note of this. Well, everybody can make a note of this, but it's mostly to the Mac people. There are two versions of Python. There's Python 2.7 and Python 3. And when you look at those two, you might say, oh, well, Python 3 is obviously the upgrade to Python 2.7. Well, Python's been around for a while. And a whole lot of people wrote a whole lot of code in Python 2.7 or Python 2. Whatever. So when Python 3 came out, there are some differences in the syntax. So rather than requiring people from who have already written tons and tons and tons of programs in the Python 2 ecosystem, they kept supporting that. So you actually have two separate products from Python. You have Python 2.7 now, and then Python 3.0, blah, blah, blah. I think it's 3.7 right now, whatever it is. So these are two separate, completely supported products right now. If you're a Mac user, what's installed on your computer is Python 2.7. What we are looking at is Python 3. Whatever, the newer version of Python. Starting next year, they're phasing out the Python 2.x line. So Python 3 is the future of Python. Any new software applications that are being written are very likely to be written in Python 3. So that's what we're looking at. So even though on your Mac, you already technically have Python installed, and if you go out to the terminal and you type in Python, it'll be your Python interpreter, and we'll talk more about what that means. It's actually running it through the Python 2.7 interpreter, which maybe for 80% of the time won't make any difference because the languages are largely identical. But every now and then you might do something that I teach you in class that is for Python 3, and it doesn't quite work identically to that in Python 2.7. So you want to make sure you have Python 2. Or Python 3 installed in your machine. Raspbian already has Python 3 installed, but I'm just kind of throwing that out there for those of you who are going to use a different version of Linux, or who are also going to try to do some of the Python stuff on your regular computers. What we're going to be using is Python 3 in here. Everybody cool with that? And if you're currently a Mac user, what came with your Mac is Python 2.7. Whether that helps you in this class or not is somewhat insignificant. At some point in the next 4 years, in one of your classes, probably in the artificial intelligence class, when you go to install some tools, a bunch of stuff is going to break, because it's going to say, you know, found Python, but the following code broke. It's because that code was written for either Python 2.7 and you're trying to rate it for Python. You run it in Python 3, or it was written for Python 3 and you're trying to run it in Python 2.7. So just something to kind of keep behind the scenes somewhere. I'm not testing you over this idea, but know that there are two versions of Python and they're not 100% compatible with each other. Cool? All right, so you'll go through, you'll get your environment set up. So you'll watch this video, install Raspbian on there. Like I said here, it's not a requirement that you run Linux to write Python. We're running Linux in here to put you out of your comfort zone, introducing you to a new operating system, something you haven't likely worked with before, using some new tools that aren't necessarily amazingly great tools. It just happens to be what comes with Raspbian. And I want to strike that balance between, hey, I want you messing around with some new stuff, but at the same time, I don't want this class to become this IT class where you're installing 4,000 gigabytes of software. You know, let's hit the happy medium. Install a little something, get introduced to virtual machines a little bit, and then let's focus on coding. Everybody cool with that? Okay. So in any case, between now and our first programming assignment, watch this video. This is on slide 8 on the slides, to install Raspbian in VirtualBox. If you're a Mac user and you already have Parallels, you can install Raspbian in Parallels. If you don't know what I'm talking about, use VirtualBox. Parallels is a expensive version of, that's what I use on here, but it's like a professional level virtual machine for computers. But VirtualBox is free, won't cost you a dime, and it's fine. It'll do what you need it to do. I also gave you a wiki page to go ahead and read related to Python. So, you know, this will give you an idea of where Python fits in the world of programming. I'll be teaching over the next couple of weeks effectively the contents of that page and then some. So these are not, well, I say these are not homework assignments so much as to say it's that I will expect your first programming assignment to be submitted using Raspbian and Linux. So one way or another, get that set up. Between now and your first programming assignment, here's the tutorial video for doing it. And I'll be teaching you the stuff from this reading thing. But if you want to kind of get a overall overview to it, let's say, you can kind of read through that and get a jump start on what I'm about to talk about. All right, I already talked about Slack. So here's a link to the channel in case you didn't write that down. It's also on Blackboard. Again, check that often. I post stuff on Slack often. And you should all post stuff on Slack often as well when you have questions about assignments, or, you know, if I forgot to put an assignment up and somebody wants to start complaining, hey, where did the assignment go? Or did he forget to unlock it? Whatever. I'll see it. Everybody else can see it. You guys can shame me online. That's fine. I'd rather me be told 25 times than told 0 times. Okay. So let's get into it then. So I've mentioned this already. Programming is a skill set. The language doesn't matter. True statement. And I'll actually kind of throw this out there. Like, how many of you in here speak a second language? Or we all just English? Okay, so we got a couple of people who speak a second language, or a third or fourth language, whatever it is. Now, when you're speaking to your friends in English, and then you're speaking to your friends in whatever your second language is, your processes in your mind are the same, right? The things you're thinking about are the same because you're talking to a human, right? You're communicating with a human being. You're trying to get ideas across to a human being. Now, whether you're speaking the syntax of English or the syntax of Spanish, let's say, your thought process, your problem solving approach is still, I'm communicating with a human. Same thing's true with computer programming. We're ultimately communicating with a computer whatever that means. We're going to get into that. We're just using different tools to tell that computer what to do. In this class, we'll be using Python. The next class, we'll be using Java. In the next class, we'll be using C++. In the programming language theory class later on, where we actually write our own programming language, we'll be using a programming language called Scheme. In the systems programming class, we'll be using a programming language called C, which is the non-object-oriented version of C++. So throughout the program, in the software engineering class, you'll be using C#, which is a .NET language. So throughout the program, you're going to be introduced to a whole bunch of different programming languages, which are all industry standard languages. Things that when you go out and get a job or you go look at current jobs in software development, you'll see that they all require one or more of those languages. But what you'll see is as you get farther into the program, you're not learning those languages. You're just using that tool to continue to tell a computer what to do. But we're keeping you off balance just enough that you're still forced to learn, and you don't have students as seniors saying things like, oh, I'm good at Python, but I'm not very good at Java. That statement doesn't actually make any sense, because you're either reasonable at programming or you're not. It's not the language. All right, everybody gonna believe me for that, at least at this point? All right. So as a computer programmer, we approach the problems we may run into on a daily basis with an additional tool. We should always strive to solve problems with the right tool for the job, whatever that is. Now, this is kind of just a problem-solving approach. Most of you in here are also in CSC175 this semester, right? So with Dr. Wall. So that class is not a programming class. Instead, that class is a introduction to computer science class with an emphasis on solving different kinds of problems using technology. You know, what's the right tool I use to do something? You know, if you have a picture and you want to put bunny ears on it or something like that, that might be a Photoshop job or one of the free versions of things like Photoshop. You choose the right tool to accomplish the task that you want. You know, something that's come up a lot this particular year is, you know, signing PDFs and things like that remotely, since, you know, we're, you know, not face-to-face for a lot of things. So, you know, again, you use the right tool for the job. I use Preview on the Mac. Some people use Adobe Sign and Fill and Sign, whatever it is. You know, there's several different apps that allow you to do it. So you pick a tool that allows you to accomplish the task that you need to do. And a lot of these are software-based tools. All right, so we always want to have this mentality of picking the right tool for the job. And sometimes there's multiple tools that would be considered the right tool, right? If I'm going to write a little computer program that does something, you know, I could pick one of a bunch of different languages, but, you know, maybe if I'm on a computer that, well, let's say you're on grandma's computer that has no programming language stuff installed on it, but I want to, you know, I'm solving some problem that, you know, would benefit from writing some code real quick. Well, web browsers know how to run a computer programming language called JavaScript. So I could just write the code in JavaScript, open it up in Internet Explorer, or what is it, Edge now, or, you know, Firefox or Chrome, whatever's on the computer, and it'll run that JavaScript, and now I have the program written. That was the right tool for the job, given that I had a machine that didn't have anything else installed on it. Right? Kind of the idea of if you're at home and you need to fix a problem and all you have is a screwdriver and duct tape, you figure it out. You know, the whole I can fix anything with duct tape problem. Okay. So the core piece here that I base all of this on. So if we're starting to pour our foundation for our house and, you know, we got the concrete flowing now, it's this idea. The job of a programming language is to allow us to tell a computer what to do. And because human beings are greedy, every one of us are, even if we think that we're good Samaritans, we're all greedy, and we're not really willing to drop down to the computer's level, right? How many of you have one of those 2-button keyboards just pumping out zeros and ones all day long? Yeah, not really our cup of tea. We change majors pretty quick, right? All right, so the idea here is that a computer scientist is going to say, look, I'm a good guy. I'll come towards the computer 1%. So 99% of the time you have to deal with me as a human. I'll be a little bit weird, and 1% of the time we'll deal with the computer side of things. All right, maybe it's being exaggerated. Maybe it's more like 90-10, but it's much closer to the human beings version of things. We definitely get the better end of the deal. All right, so if these programming languages and the other tools that sit between us and the actual processor of the computer, if these guys have to solve the problem of converting what a human being is telling it to do into something it can actually use, it has to be able to abstract how human beings actually solve problems. All right, so I abstract it down to these ideas. As a human being, we use our memory, we ask questions, and we repeat tasks until a problem is solved. You know, you see in movies, and maybe some of you have, you know, examples in your actual families, but, you know, movies try to make light of it, where you have, you know, somebody with short-term memory loss, and you walk into the room and, you know, they introduce themselves every 30 seconds or something like that. You know, think about how debilitating it would be if you didn't have your memory. If you couldn't just, you know, I say, hey, what's your name? And you couldn't just immediately spit out what your name is. What's your phone number? What's your address? You know, what were you in the middle of doing right now? So we leverage our memory constantly without even thinking about it, right? It's just something we rely on. Same thing, we ask a lot of questions. Usually the first day of class, especially when we're face-to-face, you know, I'll ask the question of, you know, how many of you got to class today without bumping into any walls? And you got the couple of smart Alex who'll say like, oh yeah, you know, I bumped into some walls. But generally, if you're looking at the halls at the school, what do you see? You see everybody's heads down while they're texting, right? They're bobbing and weaving in and out of people without even looking. Well, so does that mean walking is really easy? Walking is not easy. How many muscles in the body do you think are involved when you take a step, when you walk? A lot? A lot of muscles are involved. And I assume that when each of you take a step, you're thinking about whether you're extending or contracting every single one of those muscles. Thinking about all the little details, like, okay, I need to extend the calf, hit with the heel, rotate forward. Oh, you're not actually thinking about that every step you take, right? Okay, we're so practiced. So here's another true statement. This is why computer programming is hard for humans, and it'll probably be in one of the next couple slides anyways, but I'll say it now. Computer programming is hard. You heard me say that earlier today. And the reason it's hard is because we are so good at solving problems that we have trouble articulating how we solve them. If I tell you to teach me how to walk, you know that is a problem with, I'll just assign a number to it. 500 individual little steps in the recipe to walk, okay? We're gonna be able to say like 4 things. Like, look, just step forward and try not to fall over. You know, something along those lines. We can't articulate it. You know, even then, when I say it's 500 steps, pun intended, I guess, 500 steps to take a step. We might even think that's an underestimate, but whatever. That sounds like a very complex task. And I'm saying that people in the halls can't even pay enough attention to that. It doesn't take up their whole brain. They're sitting there texting, playing games, whatever it is, you know, as they're zipping in and out of people, just glancing up every, couple of seconds, something like that. So we are so good as human beings at solving problems. We're too good at solving problems that we have trouble articulating those solutions, which makes computer programming hard. If you're talking to a human being, you're going to have a party tonight, which with social distancing, of course, and you're going to invite your new best buddy Mike to this party. You're going to, say, okay, yeah, I'm on Main Street. You pass the gas station, and it's like 3 lights down. Turn left. And I'm like the 3rd house on the right. There's a pink car in the driveway, something like that, right? Human beings will be able to fill in the gaps and kind of figure that out, right? They'll hunt and peck, they'll get to the place, because a human being doesn't require completely granular instructions. We're smart. We're like, well, is he talking about this gas station or this other gas station? There's the pink car, and this must be the place, whatever it is. But a computer isn't like that. The computer needs completely unambiguous instructions. Every little step can't be interpreted any more than one way. And that's something that's difficult for human beings to do when we've spent our entire lives working with other human beings to solve problems. And now we have to talk to this, very kind of a stickler, our computer, which only understands things one way. And if we give it one little misstep, we'll get a whole wrong answer. Okay? That's why computer programming is hard. We're too good at solving problems. And we're used to working with humans, not with computers, and computers are inflexible. All right? But going back to the asking questions part here, as you're walking down that hall, even though you're barely paying attention, you're staring at your phone, whatever, bobbing and weaving, you're constantly asking, do I need to go left? Do I need to go right? Am I going to hit something? Am I falling over right? Am I falling over left? But how many of you realize you're asking those questions? We would drive ourselves crazy, right? You don't realize you're asking a question every quarter second in your head about, how do I shift my weight left? Do I shift my weight right? You're not recognizing you're asking those questions, but we are. We know we are, because we're making adjustments as we're walking down the hall, only when we glance up from our phone, but we're still making those little adjustments to bob and weave out of the traffic. So we're constantly asking questions and reacting based on our answer to those questions. All right. So just as all computer programming languages will have facilities for mimicking our memory, allowing us to remember our name. My name is Mike. My phone number is this. My age is this. All sorts of things like that. We can create name value pairs in any programming language. These things are called variables. It also is going to have facilities for asking questions. These are usually called conditionals. For me to say, am I going to hit something? If yes, dodge. If no, hold the course. Something like that. All right, so we'll have facilities for asking questions in every single programming language. Repetition. Repetition is something human beings use often. When we talk about walking, we've abstracted the idea of taking a single step, and we repeat that over and over and over again, alternating between feet until we get to where we need to go. We already covered there's a lot of steps there, but repetition is something that's common in the way human beings solve problems. Okay, so we all feel pretty good about that. If we were, you could probably make an argument that, oh, well, there's some other little inserts you can put in here for how humans solve problems. But in the big scheme of things, does this kind of capture it? We remember stuff, we ask a lot of questions, and we use repetition. And if any one of those things was removed from our ability list, we would be pretty hampered on the types of problems we could solve. Fair enough? So, like I mentioned a little bit, 100% of programming languages will have facilities for these three things. Okay, they'll be able to accomplish these three things. Memory is done through variables, name value pairs. Asking questions is done through conditionals, if statements. Repetition is done through loops, as well as functions, subroutines, things like that that we'll talk about. All right, but the important thing from this slide is the idea that it doesn't matter what the programming language is called. It will have facilities for these three things. If it doesn't, it's not a programming language. Okay, and let me give you a quick little example here. One thing we'll make it interactive so people get to talk and I can take a drink. What programming languages have we programmed in before? Some of you are going to have some background in programming. So what languages have we used? Just unmute and start blurting it out.
HTML.
Perfect.
Experience JavaScript.
Yeah,
JavaScript. Okay, what else?
C#.
All right, so let's focus on the HTML bad answer. So now, in fact, I'm going to probably add a slide here. Well, here, let me just add it and then we'll. So HTML, let's focus on this for a second. This might be repeated somewhere else in here, but I'll, whatever. Anybody know what HTML stands for? It's hypertext, markup, language. Doesn't matter. What is this guy? It's our web page language thingy. That's what that guy is, right? We use that to make web pages. All right. So now back to this slide here, though. So those of you, how many of you have worked with HTML before? I'm guessing in high school or something like that, somebody made a website or something, you had to do some HTML stuff. Maybe a lot of it was you used some tool for dragging and dropping, but at some point you had to look at the weird tag things, you know, the opening body tag, closing body tag, you know, H1, the divs, opening div, closing div, those things. So in HTML, can you create variables, name value pairs? Can you say, I want to remember my name is equal to Mike? Can't do that in HTML. Can you ask questions in HTML? Nope. Can you do repetition in HTML? Nope. In fact, the evidence is right there, because when you create websites, I'm sure there's at least a couple of you who've done some websites before. What tools do you use to create websites? You use
JavaScript.
HTML. Yeah, HTML, JavaScript. And what's the last one? That's the common kid there. CSS, cascading style sheets. So HTML is how it looks. JavaScript's the programming language. That's making it dynamically work. CSS is how do I make it have a consistent look and feel across all the pages? You know, so that way you don't have to, if you change the background from green to purple, you don't have to change it on 30 pages. It can just change everywhere by changing it in one place, that type of thing. All right, so HTML is not a programming language. Now, don't take that the wrong way. That doesn't mean that it's a waste of space. HTML solves a very, very, very important job. This guy is a data representation language. It's a way of formatting information in such a way that another program can, in HTML's case, turn it into pretty pictures and text, right? And what's the name of that program? It's a web browser, right? Web browsers read HTML and they turn it into formatted text with images and video links and all that stuff, right? Okay, so it's not that HTML is a waste of space, it's just not a programming language. It's something else. It's the right tool for the job to solve the job of making web pages format nicely. All right, and we could go on with HTML-y stuff, but I'm sure at some point in here I start getting into XML and that kind of jazz. So we'll just trust in the slides for a little bit and go from there. Okay. By the way, I don't usually teach from a pre-created set of slides like this. This is more for the COVID response, but I usually just start with a blank slide, just let the class grow. Then we get off on tangents, but that'll still happen, trust me. We'll still have fun. All right. So each new slide will be a surprise for all of us. It'll be great. It's like a present. So we've already kind of talked about this. Why is programming hard? People are good at solving problems. We're too good at solving problems, and we have trouble articulating how we solve those problems. Okay, that's why it's hard. We already talked about the stuff in this slide. This was that whole inviting me to your party thing. All right. So programming language is the right tool for the job. This tool allows human beings to tell a computer what to do in a way that's similar to how we already solve problems. That's the whole 99% like a human being, 1% like a computer, and they're lucky we're giving them that much. All right, it's still going to be intimidating. Okay, for those of you who ever had to take a natural language, you know, you tried to take Spanish or French or whatever, German, in high school or whatever, you know, it's still intimidating when you need to learn how to say, you know, library in a different language, right? You learn the vocabulary of that different language. But once you get used to it, you realize that, you know, half the words kind of sound the same. If the language you already know came from kind of the same classification of language as the one you're trying to learn, but it's still weird, right? So there's going to be an intimidating aspect to learning a new programming language, and that's the syntax. It just, you know, when you hear the word code, that has this intimidating idea that goes with it. But once you get used to it, once you've written an if statement enough times and you realize, okay, well, I say the name of the variable equals the value, and that's just how you define a variable, and that's how it works, you'll get used to it. The syntax is just a means to an end, okay? It's kind of like learning how to speak to Siri or Google Assistant. You know, you got to kind of learn the right way to say things. When doing, you know, now we have well, I do this all the time when I'm leaving a message on somebody's answering machine. You insert commas. You know, you say like, you know, hey, how are you doing, comma. It's like you're just leaving a message for another human being, but it's as if I'm talking to Siri, so we're reprogramming ourselves to be idiots. But in any case, there'll be an intimidation factor of the syntax. But the harder part of programming is going to be that task of breaking problems down into their small pieces, because that's the part that we're not very good at. Human beings, you know, we talked about walking a few minutes ago. Walking is so trivial for us that we just take it for granted. It doesn't even deserve our full attention. We're texting while walking, texting while driving, you know, whatever it is. But, you know, when we actually need to stop and tell a computer what to do, we have to teach ourselves how to slow down and actually break those problems, break the solutions to those problems down into little tiny baby steps. That's going to be the part of this that's the hardest for you to bridge. And that's where practice through the homework assignments is going to come in. Because what's going to end up happening when we start getting into the programming stuff is you're going to spend a lot of time in your assignment. Then we're going to come to class. I'm going to solve it in 3 minutes. And you're going to be like, that's all it was? Because you're not practiced at that transition yet. Okay? So programming languages are human-created tools. We cheated. So we said this already. Rather than be fair to the computer and create a programming language to meet the computer halfway and be a hybrid of a natural language like English and a machine language like binary zeros and ones, humans created programming languages to be much more natural language-like, giving us the advantage in a human-computer relationship. I already mentioned this. Programming is like a sport. You know, I can go out. So, I mean, I'm a big golfer. I used to be a Division I tennis player a couple of minutes ago, and I broke my back, and then I got fat. So, is what it is. But, you know, so when I first started playing tennis, my dad was a top college player, and my brother and I were playing tennis once we were old enough to hold tennis rackets, whether we liked it or not. We were playing tennis. And, you know, my dad could teach me how to academically hit a topspin forehand or something like that. But until I hit 10,000 of them, you know, it wasn't all that great. You know, it took repetition, practice to get those moves down. I'm an avid golfer now. I play golf pretty much every day. And, you know, I'm a fairly decent player. And, you know, I can go out and take somebody who's a beginner at golf and I can say, okay, well, here's how you hit a pitching wedge. Here's the stance, here's the grip, here's all this stuff, and I can take a swing and it looks easy, you know, but then they take a swing and they might be a really athletic person, but they swing and whiff, or they hit the ground a foot behind it, whatever it is. It looks easy when you see somebody who has practiced do it, but until you've put in those reps and gotten better at it yourself, made all those mistakes, made the little adjustments that are compatible with how your body works, how your mind thinks, things like that, you're not going to get better at it. All right, so really try to compartmentalize computer programming in that context, because it's not going to be something you can just kind of blow off the class until the night before the midterm, then cram reading through all the slides and come in and think you're going to do well. You won't. You know, that's like showing up to the first tennis match after just sitting there at practice watching other people hit the ball and never actually doing it yourself. You're going to be in trouble. All right, so this is the don't freak out slide. Many of you are going to struggle with programming. It's going to be hard. I promise you, stick with it. I'll be the first one to tell you if I don't think you can cut it. But I'm giving you fair warning here that you are very, very, very likely to suck at it for a while. So allow yourself to not be very good. Okay? That doesn't mean that you can't handle it. It means that you just started practicing baseball or just started practicing tennis or whatever the sport is, and it just hasn't quite clicked yet. Hence the reason for the self-assessments, hence the reason for the do-over on the midterm, all those things add up to, you keep putting in the reps, and eventually you're going to, things are going to start clicking for you. Things that you thought were hard 3 weeks ago will start making more sense. All right. So this next thing here is, and we'll kind of call this our last, because we're done at 11:20. Is that when this class is over? Okay.
Yeah.
So in any case, computer programming is a superpower. So you can make a lot of money as a computer programmer. Not that money is the driving force for anything. I think everybody has a God-given gift, and we want to help you identify those talents as early in your college career as possible to make sure you're putting your time, effort, and tuition dollars towards the thing that God's made you for. But if we assume that computer programming is going to be one of your those talents, it is a superpower. Not very many people can do it. Not very many, and even fewer people can do it well. And it's going to pay you quite a bit of money. And if we look at modern trends right now, it's done very well during this pandemic, where a lot of people were displaced from their jobs and things like that, where computer programmers were able to still work at home. No big deal. In fact, probably there's been a trend now where you're going to see a lot of software companies downsize their real estate footprint because it's easier just to have their people working at home. In fact, we have a former computer science major from Concordia who works for a company in New York City but lives in downtown Milwaukee, and he's getting paid New York City dollars living in the Midwest, and everybody wins. So he's making more than he can make here, and they're paying him less than they would have to pay somebody there, and everybody's happy. So he's making, I don't know, 100,000 when they'd have to pay somebody 120,000 there, and he'd only be paid 80,000 here. So everybody kind of wins. But computer programming is a superpower. It is worth it. Put in the reps, and you'll end up, kind of think of it as being a ninja or something like that. Okay. Questions, comments, concerns, bribes. So if you want to kind of get started on things, go to the very beginning of Unit 1, slide 8 here, and start going through this video, setting up your environment, virtual machines. I'll expect this to be ready for when we first start having programming assignments, probably end of next week, early the week after that, something like that. So start incorporating this into some of your time. Also, don't forget, if you have a strong feeling about meeting face-to-face and you have not emailed me yet, email me as soon as possible today so I can add you to the list. I'll follow up with a message to the whole class. Tomorrow I'll do it on Slack as well as email for now, since everybody might not be on Slack, but making sure that people who have, letting you know that we have enough room for the people who want to be face-to-face, and we'll give that a shot for Thursday, okay? So Thursday we'll be on Zoom, we'll also be face-to-face, so it'll be the same format, but I won't be sitting at my house, I'll be sitting in the classroom, and we'll see how that goes. That sound good to everybody? All right, I will see everybody on Thursday.
Thank you.
Yep, take care.
Hey, Mike.
Yep.
It's okay if we use Ubuntu?
Yeah, I'm fine with that. Just the examples I'll use in class will be using
Raspbian.
Yeah. But yeah, I don't care what you do. As long as you're using Linux, you're out of your comfort zone, I'm happy. That's the only purpose of Raspbian.
Okay, thank you.
Yep.
I got one question quick too. So I tried emailing you during class just because I would prefer to do face to face. And I sent you 3 different emails, but for some reason it literally won't go through. So
Won't go through?
Yeah, every time I sent an email, I got a message back that was your delivery has failed to this recipient, and
What
then it said
address
just
did you try to send it to?
let's see. Michael Littman at concordiauniversity.edu.
It should be Michael dot with a period.
Yep.
Littman, Litman.
Yep.
At cuw.edu.
Yep, that's what it is.
Okay.
I don't know why.
Go ahead and send it to awesomefat@gmail.
Okay.
The word awesome with an FAT at the end of it at gmail.com, and I'll get it.
Okay, sounds good. All right.
Yep.
Thank you.
I also have a question.
Sure.
So you said you'll record all the classes. I think I'm just going to do the Zoom classes It might be a stupid question, but would I have to show up for the live video then?
Well, I mean, I personally don't care if you show up for the live video or not. I mean, I guess the recommendation is, yes, you should show up for the live video if you want, you want the opportunity to ask questions during class and stuff like that. But if you don't want to do that and you trust yourself to watch the video later that day or something like that, I'm fine with it. Doesn't matter to me.
Okay. Thank you.
Yep.
Have a good day.
All right. Anything else?
How do we get to that unit 1 part that we have to do before
If you go into Blackboard, the link that says course slides should take you to my slides,
all right.
the exact ones I'm using.
All right.
So
Thank
whenever I update something, it'll automatically update in there.
Okay. Thank you.
Yep. All right. Anything else?
Oh, I have a question.
Sure.
I couldn't find the exact section of the Bible which I should read.
It should be under content. You mean on Blackboard? So if you go into Blackboard, click on content, and then there should be a folder that says Bible homework.
Bible homework. There is only word that read these chapters in the Bible and write a few paragraphs reflecting on what this meant to
Correct.
your life.
Yep.
What is the exact part of the chapters?
Acts 1 and Acts 2. It's in the subject. So Bible homework 1 is read the book of Acts, which is in the New Testament, books chapter 1 and 2.
Thank you.
Yep. All right. Anything else? All right. Well, if there's anybody in the waiting room for my next class, I'm going to end this session. I don't know if it's going to kick you out or not, but just rejoin because that's how my recording will get processed. And then I'll come back in for my next class.